day. Had a student question that popped up regarding our arbor press project, and it related back to the cover plate and the screws and screw depths and so forth. So we're going to go ahead and show you the creation of the cover plate, or a demonstration of how to create an object already in an assembly, locating the screw information, and then also transferring that same information to the column that is created for our arbor press. So bottom line is we'll get started with this, and we'll go from there. So the first step is that when you're creating something that's in an existing assembly, you want to right mouse click on the top level to create a new component. If you try to create the component inside the existing assembly, you can create it as a separate object and bring it into the assembly, but you can't really create a new component by just clicking and going. You have to actually choose the new component, because it's going to create, and we'll call this cover plate. It'll create a new item on the list as a object to develop, and then it will ask for you to create a sketch, and we can pick one of the standard sketch planes, or work on the object kind of a thing. And it doesn't really matter which sketch plane you use, because of course you're going to be utilizing the assembly tools and making a joint between the object and the other components. So ultimately, we can create the shape. Create the shape here on this base level. And so the shape that we're going to create is a profile, and we're going to revolve it, because that's usually the easiest when you're working with a round object with multiple features, is to create a profile. You could create this as two discs and extrude one disc and extrude another disc, another circular object on that. Both will work really well, because this is a simple object shape overall. So what we'll do is I'll do a quick sketch of the shape of the object, and what I'll do is I'll drag this point over. And that's the advantage, is that before you add any dimensions or constraints, you can drag the data points around and so forth. So the profile of the shape looks like this. We'll start to add our dimensions to it overall. But before that, I'm going to make this line a center line. And so I'll right mouse click and choose a center line basis. I do that because that's going to be the point of revolution of the object, and it also triggers this unique dimensioning feature. So if I pick the center line, pick the outer edge here, that's supposed to be a total distance of 1.75. Alright, so you notice what happened is that now that I changed the overall size of this, it folded on itself. And so what I can do is left mouse click and hold. I have to get out of the dimension command, so I hit the escape key. Left mouse click and hold, and I can drag this line because it doesn't have a constraint associated with it. And so that's the advantage, is that you can drag the components back into normal shape, because the objects being folded upon themselves happens fairly often, especially when you initially set up dimensions. So I'm going to go center line to this vertical line. Oops, let's try this again. Center line, vertical line. Oh, it's definitely not cooperating. So we'll go this line to the center line. Now that worked. And that one happens to be 1.170. And you'll notice that this is a unique dimension. It's called a linear diameter dimension, or dimetral dimension. 1.170. And so what that does is that gives a diameter distance, the overall distance, if you're working from a center line. If the center line was just a standard line, I would have gotten a radius distance to work with, but having that center line, it creates that linear diameter. All right, we have a couple more dimensions to place in there, the overall and the shorter dimension. So I'm going to put the short dimension in first. That's another tip, is that you can work from smaller dimensions to larger dimensions and things won't fold upon themselves. And this one happens to be 0.57. And so that's our ultimate shape of our object. We'll then finish our sketch and revolve this particular object. Now, a lot of times what will happen is that it's going to ask you to select the shape, and slide this over. And it also wants to know where the axis is. So I'll pick that center line as the axis point. And there you can see how it's going to revolve at 360 degrees. And it's a new object called a new body. So that's the cover plate. Now we have to drill some holes in this cover plate. So creating the holes in the cover plate, I need to put a sketch on here because I'm going to use a tool called the point command to locate the first hole. And that will help us ensure that that hole is positioned properly. So I'm going to do a sketch, put the sketch on the face, and now I can look at the object straight on. And for this, I always draw a center line. Okay, now where's the center line based? Well, the center line is based in the center, and you can see as I move, I find the center point. So once I find that center point, I locate it and draw a vertical line all the way above the shape of the object, escape, and then I can use it as a normal center line. That gives me the vertical center line that I'm going to be working with. The second thing that I'm going to do is create a point command, because the line or the hole is on that vertical center line at a specific location of 0.725 from the absolute center. So again, I'm going to go ahead and ballpark it. I don't know exactly where that is, so I'll pick that point, hit the escape key to get out of the command. And yet now you can see that there's a point position on there. So from that center point to this point, I need to have a dimension of 0.725. Okay, so that's going to be the center of the hole. Well, we're done with the sketch. All we need to do is put this one hole position in. And with that being done, I can now use the hole command. Now, the hole command is unique in that it allows us to create a variety of different styles of holes and features within the hole, meaning threads, tapered threads, counterbores, countersinks. In this case, the hole is a counterbore hole, where the screw actually is recessed into this plate. Now that counterbore hole is just a simple through hole or simple hole through that object. And it's actually going to go all the way through, so we're just going to say all. Okay? And so when I pick this point, when I pick the face or the sketch point, in this case it's the sketch point, it's going to put a hole position here that's based on the counterbore hole. Well, the counterbore itself, and it tells us that the counterbore diameter is 0.26, and the depth of that counterbore is 0.21. So the diameter of the counterbore and the depth of the counterbore happen to be entered. Now the hole itself is a through hole. Well, this through hole is a 0.172 diameter. Now that's kind of an odd size, but the whole idea is that the screw is going to slide through this and then thread into the column. And so we want this hole to be slightly larger than the diameter of the screw. And we'll choose OK. Since we had that point already selected, it automatically created the hole itself in the object in the right location. Now, as you can see, there are 3 holes, 1, 2, and 3. All of them are 120 degrees, which means that's 3 holes in 360 degrees. Well, there's this cool feature that allows us to do multiple copies. It's called a pattern. And the icon shows a rectangular pattern. However, when you pop it up, you have the ability to do a circular pattern. So we have to select the object, and you can actually select it from the list of objects if you wanted to pick that body, or you can just go up and select the hole itself, the edge of the hole, as that feature. And the axis of revolution is actually the outer circle. Okay, so you can pick the outer edge. As long as you pick a circle or an outer edge, it's going to know where that center axis happens to be. So we're going to go ahead and highlight the axis. I'm going to pick this circle. It'll use the center of that circle as the axis. And it says 3. So we've got our 3 positions. But what if we wanted to go 4 or 5 or 6? And it will automatically calculate based on the 360-degree positioning where the hole should be. And so we're going to go ahead and choose OK. And now we've got our 3 holes in the correct location for our mounting plate. Now we also have a hole through the center for the shaft. Okay, so we can use the hole command to do the same thing. So if we choose the hole command and I pick the face or sketch point and I kind of ballpark where the center is. If I pick off, let me do that. So I'm going to pick the hole command. I'm just going to pick off center, just so it's physically off center. The reference that I want to use, it says add a point, single hole, or that. Well, I need to find that center point because I need to make sure that this hole gets moved to that center location. Now notice when I left mouse click and hold, what it pops up. It pops up all the center points that it can find on that surface. So I know that the center point in the middle is where I need to be, and it will lock it into place. It kind of jumps into place for that center point, making it easy for positioning. Now this hole is going to be a simple hole, a simple drilled hole through the part. And it's going to go all the way through. And this one happens to be a diameter of 0.25. And so that's it. We drill a simple hole through that part at 0.25. Well, that plate is now complete, but it's also now part of the assembly, which makes it nice so it can be used. Okay, so now we need to go back to the column and we'll right mouse click and activate the column. Well, why do we want to activate the column? Well, we want to activate the column because the column needs to have holes drilled on this side to meet that mounting plate. So the same thing is going to happen with this column, is that we're going to have to lay out a sketch, put a point on, and then create the multiple hole positions for that object. So we'll put a sketch, since this is our current object right now is the column. I'm going to go ahead and put a sketch on the side of the column. Because ultimately we're editing this column now. And then for this, I can go ahead and create a line, but here's a little tip. To make it easier, what I do is I'll project, use the project, not project, but project, different emphasis. I'm going to project the circle to the current sketch. Okay, the sketch is on the surface of the part, but I wanted to project that circle so that way I can easily find the center point, draw a vertical line, and then make this vertical line a center line. Now, the line that I projected, I could right mouse click and make it a construction line or a center line if I choose to also. But the whole idea is that we can make this a line that allows us the ability, let's see here, normal center, there we go, and this normal construction. So you can see that the lines now are a center line and a construction line, so that way they won't get mistaken for an actual object or a shape. So now we need to put a hole in this location somewhere for the screw to thread into. And again, we could do this without using the point command, but I like adding that little extra step of throwing in a point just for that level of accuracy. So I'm going to pick this location. We've been down this road before. This dimension is a 0.72 dimension, 0.725. That matches up with the same dimension that's on the cover plate. And so now with that being done, I can finish the sketch, use the hole command, pick the point that the hole needs to be at. Now when I do that, it's going to use the last hole, which was a drilled hole. Well, in this case, we have a drilled hole, but we also need to tap it. We need to add threads to that hole. But that hole size is not a 0.25. The hole size needs to be a number 8-32. So what we have to do is find a number 8 screw, which in this case is a 0.164. Remember, the through hole on the cover plate is 0.172, so it's larger. It gives that little bit of play to thread that screw into the threaded hole here. So this is a number 8. That's where the 8-32 comes into play. So let's select number 8. And you'll see that 8-32 is the default designation. There is an 8-36 also. So this is an 8-32. But the real question now, the default is the diameter, that is given, but it doesn't know is what is the depth. So realistically, you can control the depth on this particular object. Now the width of the column is only 1 inch, so if you went 0.457, you're going halfway into that column. Well, halfway into the column may run into the rack. So let's do it as a 1/4 inch, okay, to hold the cover plate on, 0.25. So the depth is going to be a 0.25 depth, and we'll choose OK. Now that 0.25 depth plus the thickness of the cover plate, which is roughly 0.2, let's see here, it was roughly 0.33. So 0.33 plus a 1/4 inch is roughly a 1/2 inch length, 8-32. So now you know what the length of the screw needs to be that you bring in is 8-32, about a 1/2 inch length. You have to give it a little bit of distance beyond the drilled hole, or making sure that the drilled hole is deeper than the distance of the screw so it does not bottom out in that hole. Same scenario with the multiple copies. So the feature that I'm going to pick is the hole feature. And the axis I need to select is the circle. Okay. Now if I can't pick that object, if I can't select the circular pattern, that's what I didn't put a circular pattern up. Now I need to pick the axis as the circle, and again we have 3 holes and everything's perfectly okay. So make sure that you check and that it's not a rectangular pattern, that it's a circular pattern in that process. So you notice that 1/2 inch, where's that 1/2 inch? Well, that 1/2 inch actually goes all the way to the rack. You can see the rack inside here. So be aware that you can't go beyond that 1/2 inch. If we went beyond the 1/2 inch, you'd actually see the point on the rack that it would fail on that particular process. So now we've got our 3 holes, we've got our cover plate. We can then use the joint command to align them up, and then we can also now insert our screws into that process. If you're going to insert screws, you'd want to use the insert McMaster car component from the insertion on the ribbon. And again, this happens to be a socket head cap screw 8-32. You'd want to go no more than a 1/2 inch length. And so you're able to pick that up very easily through the McMaster car component environment to develop that screw position. That's all I've got. Have a great day, and we'll talk to you soon.